what's new in Swift 6? A small talk that I wanted to do, just to give a brief overview of what has been developed on the for Swift 6. As you know, it's a newer major version of Swift. We've been using 5.6 for 3, 4, 5 years now, and as part of Swift 6, there are multiple improvements to the language that come and that I think are really exciting. So this is pretty much what we're going to talk about. So first, data race safety in Swift 6. You might have heard that around even in the current version of Swift. And I'm going to mention quickly how Swift, improvements between the current version and the Swift 6 version, and how you can take advantage of it. Then the type throws. Then mention also the changes to async sequence, async iterator protocol. Also mention that the new macro type, function body macro. Also, C++ interoperability, non-compilable types, forward scan matching for string closures, and I'll end on how you can start to migrate to that new version. So first, data race safety. So as you know, if you've done multi-threaded programming, sometimes it can be fairly hard to handle concurrent context. So like, I don't know, you want to modify a property and maybe it's getting access to multiple threads, and then you get, I don't know, deadlocks, or you get data races, which is when two threads are accessing the same variable. So currently, when you're using Swift 5 or like dispatch queues or operation queues, these can be mostly runtime errors. So that means that it will happen in like when you run your app, and this is your users that will find out that it's an issue. And with Swift 6, so there's a new mode that if you use structured concurrency, so async await, it will basically detect all of the the data race at compile time, so before you ship it out to the users, which will greatly improve the experience overall. So this should be a talk on its own already, so I'm not going to do much more into this, but it's something that is really exciting. Next is type throws. So you might have code right at asynchronous, I don't know, is combined, and you have a publisher and you want to use structured concurrency, right? But prior to Swift 6, when you converted and you had a custom error, you actually lost that type of error. So with Swift 6, you can actually specify the type of error going forward so that there's a 1-1 conversion between the combine or result code into structured concurrency, which is really nice. Additionally, there have been changes to async sequence and async iterator protocol. So in the past, if you used async sequence and you wanted to create one map one, here I don't know if it's big enough, but you had to specify the return time entirely, right? Which is not really, it's kind of hard to find that. You only know at the end. And now you can just do this, for example, using the two parameters that we added to async sequence. And it's just one of the examples on how you can leverage this change. And there are other changes to async iterator protocol and how you build an async sequence that are similar. Also, so I wanted to talk about a new macro type, function body macro, which I think can be really useful. So they can basically be used to create a function body or augment an existing one. So Apple gave the example of a log macro. For example, if you apply it to this method here, it would basically annotate and add logs when you enter and when you exit, so that you can automate this. And you can imagine many more use cases. You can also create body from scratch. So if you have, you could use the arguments to create an API call or like that, just transform it to JSON using the macro, and it can be pretty imaginative. But yeah, it's one of the new types here that we have available now in Swift 6. something that also is worth mentioning, even though it's not something that we probably use every day as iOS developers. But if you have a C++ code base, it could be very interesting, especially if you have a C++ code base that you use in your iOS app. So there are more types supported by default, which if you use C++, you will recognize. And you can now mix and match Swift and C++. So I believe it was already possible, but it was improved even further in Swift 6. So that means that you can use Swift objects in C++, but also C++ objects in Swift. Then Swift 6 provides what they call non-compilable types, or move-only type. So optional result and unsafe are not compatible with that. Saying here is something that you might not have used, but it's something that can be useful. So here I have the example of a file that is non-compilable. So you have a file descriptor, right? That's only open once, and then you just pass it around. And with those kind of type, you have to use the borrowing and consuming keywords that you might have not seen before. But on a very simple use case, here we have two methods, right? One that borrows file, one that consumes file. Borrowing means that basically the file is going to be read only in the method, so you cannot mutate it. And read file means that you consume it and you cannot use it outside of the method anymore. So here on the left, you see that I will inspect the file and read the file, and that will consume and then borrow it. So that means that if I were to reverse it, so I read the file and inspect it, you will have a compile error that says that file cannot be used after consume. So those are like specific use cases that can be used, but I think it's also a good feature that has been improved in Swift 6. And finally, wanted to talk about what could be considered a breaking change in Swift 6, where the trailing closure is changed in between 5.10 and Swift 6. Before, in Swift 5.10, you have, if you use a trailing closure in that method that has two closures in a row, it would use the bar. It would be matched with the bar argument. And with Swift 6, it's going to match with the first argument, which is through here. So something to keep in mind. And you can actually enable it in Swift 5, this behavior, if you want to see how your code base will compile. There are a bunch of exceptions and how this is matched. So this might not be a breaking change everywhere, but it could be if you have two closures in a row that have the same signature. Yeah, I wanted to mention quickly on how to migrate to Swift 6. So as you may know, Swift 6 language mode is opt-in with the Swift 6 compiler. You can compile Swift 5 with the Swift 6. And that means that if your application is modularized, you'll be able to migrate module by module. You can also choose to enable some Swift 6 features into Swift 5.10 in the current, but without using the new compiler. So you can start to migrate your project feature by feature today. A really good aspect of it is that you can actually, if you switch to Xcode 16 later on, once it becomes available for final release, you'll be able to actually compile your Swift 5 directly. And basically everything I mentioned today will be usable with Swift 6 and Xcode 16. So that means you get the type throws, you get everything except the data race safety. And that means that you can leverage that as soon as you migrate to Xcode 16, you can improve your code base using those things. There's a WWDC session that goes into much more detail. I encourage you to watch if you're trying to understand how you can migrate. Put a bunch of links here if you want to read that offline. Yeah, that's it for me. Thanks a lot.
All right. Hi, everybody. My name's John. I'm a Vision OS developer. I'm a longtime iOS developer, but for the last year or so, I've been primarily focusing on Vision OS. And there's a ton of new stuff that Apple announced this year at WWDC. I think a lot of it probably went under the radar a little bit. probably was overshadowed by all the Apple Intelligence stuff, but there's a bunch of really cool new things that's going to make our lives a lot easier. So if you haven't done Vision OS yet, I really encourage you to do it. It's a super exciting platform. Yeah, so what's new? The slide didn't change. Okay. Right, the slide change. Yeah. Oops. Oh, cool. There it is. Okay. I put together like just a giant list of new stuff that was announced. I'm not going to talk about all these, but if something here piques your interest, definitely go check that out. Timeline. This I am going to talk about, so I'll get into that after this. Blend shapes and inverse kinematic support. These are more advanced animation types that weren't available to use in earlier versions of RealityKit or just all of last year. And that's the kind of thing that people would usually go to Unity for, but this is all working in RealityKit now. View hierarchy debugging. I'm going to talk about this one in a second too. Custom SharePlay persona layouts. So SharePlay in Vision OS is really cool. If you haven't seen it, you can have personas like that for people that call in from FaceTime, and you can have them arranged around content. Before they have like just some like preset ones where like you'd be side by side or like around a table, that kind of thing. But now you can customize that stuff. Oh, cool. SharePlay in the simulator. This I'm super excited about, and I'm gonna show that in a little bit. Reality View is now available on iOS and macOS. So if you're starting a Vision OS project or something that you started last year, you can bring it over to iOS and macOS more easily. Tabletop Kit, predictive hand tracking. I'm not going to talk about all this. Object tracking, that's right now is enterprise only. Custom volume sizing. Volume is a 3D space. Might have seen this already, but if you have apps that are running side by side in the shared space, right now in Vision OS 1, they're limited to, I think it's like a set size. It's like a meter or something. Now you can adjust that. You can also put like ornaments on them. So a lot more flexibility. Custom window placement and sizing. There wasn't really much you could do in code with that before. Immersion level callback. So you now get callbacks when you adjust the digital crown. Spatial tracking session. This is something that's makes it easier to configure what's available in your app, what's allowed for spatial tracking. Like, does it allow hand tracking, plane tracking, that kind of stuff? Just easier way to do that. And there's probably a lot more that I didn't catch. Okay, so I'm going to talk about those ones. Okay, first timeline. So the timeline is on the bottom. This is something that was in a previous RealityKit before, or Reality Composer before Reality Composer Pro, but now it's in Pro, so it's available on Vision OS. You can sequence up all kinds of events and have them play back. Like you can have it, you put it like, okay, audio or moving entities. And then there's also things that just like make an entity shift and face the user. That's something that I spent like days on for this one app I was doing, but this makes that all much easier. You don't have to do it in code. So this one that I want to show is Transform 2. So this allows you to move an entity from one position and or like rotation, and you can give it a length and like a place that it's going. And you can adjust the length down in the timeline here by stretching out that section in yellow. And here's a little video of, well, let's see, how do I go back? Oh no. Okay, I won't go back. You can also put in animations. So if you just do like transform by itself, that monkey is going to move to the banana, but it's not going to look like it's walking. So this monkey model, I just downloaded this today from CG Trader. It had a bunch of built-in animations that you can access those now within Reality Composer Pro. And there is the animation. Yeah. What's kind of one thing that's kind of weird with this is you have to actually cut up the animations manually. So within like the USDZ file that you would get from like one of like CG Trader or one of those other sites for 3D models, when you bring it into Reality Composer Pro, the animations are all in one like one animation. So you have to manually cut them into these separate clips. So I went in and just cut out like a walking animation that hopefully I can play. Oh, another thing here I have on here, remember to Command S, save often. This is beta software, so this crashes on me like all the time. And yep, there was a crash. But yeah, you actually have to manually like save it. Yeah, and don't be like me and ignore it, send it to Apple. Okay, now this one I wanted to remove the banana after the monkey goes and eats it. And there's an action here that you can put in the timeline that is it's just called hide. So you can just put you can just add this into your timeline where you want this entity to be hidden. So I'll show you what that looks like. Yeah, so I'm just dragging it in. That should be after the monkey does the eating animation. And then I'll play it back. It eats it, and banana's gone. And you can trigger these timelines either in code. This is how I figured out how to do it. Like actually pull out this animation library component from like the root entity and then play it. I don't know if this is the best way to do it. That's just how I figured out how to do it. Hopefully there's a better way to do it. Another way to do it is all within Reality Composer Pro. You can put a behavior on an entity that like either by tap, spatial tap, a direct touch. I think there's a few other things too. And that can trigger a timeline. So I have the action here from on tap to be walk to banana. And here's a video of that. So tap on it and then the monkey walks to it. Cool. All right. Second thing I want to show is reality view hierarchy debugging. You might remember like with UIKit, you get while the app is after you've built and run the app, you can go into like the view hierarchy. This is kind of similar. So they didn't have this at all last year. But so this image right here is from Reality Composer Pro, and I put a square around the hierarchy there because what you see right there is not necessarily what you get at runtime. And here it is this is in Xcode after I've run the app and then press right. It's in the debugging section. There's a new button that's like entity hierarchy. So you can see it's if there's a few levels deep in there that they added like a few like parent entities in there. So that was something like before this, I was like so confused like why I couldn't like get this specific entity, and I was like iterating through children and grandchildren, and I ran my app on with this, and like I figured it out very quickly. So that was great. Okay, cool. Last thing is SharePlay and Simulator. So like I said, SharePlay on Vision OS is really cool, but it's Very difficult to test. You have to do a FaceTime call. You have to have multiple people with Vision Pros, and that's like there aren't a lot of people that have Vision Pros yet. And especially if you want to do it with like more than one participant. So this actually like simulates a FaceTime call within the Vision OS simulator. And then it shows you, you can set like how many participants you want, and then it shows you how it's, where those people are located in the space. So those like that alien, the dog, the robot, and the cat, those are my like test FaceTime callers, and that's where they would be located in the scene. But if you were actually to do a FaceTime call, you should, as long as they have like the spatial persona set, you're going to see the actual people that you're on the call with. And one thing that this took me a little while to figure out, when you do the fake FaceTime, you have to press this little Q button to get it to go into the spatial mode. Yeah, I was lucky enough to be able to talk to one of Apple's SharePlay engineers at WWDC, and he showed me that, and then my world changed. Thanks. There's my info.
So hey everyone, I'm Prithiv. My talk title is Quick SwiftUI Tips to Delight Users. I should probably have a much better talk title, but we'll actually be getting into MeshGradients and TextRenderer. These are two new APIs introduced by Apple during WWDC 24. So yeah, so MeshGradients. The MeshGradients are a new feature in SwiftUI that lets developers create smooth multicolor gradients with fine-grained control. It's an advanced version of gradients that has much more flexibility and visual appeal. So the basic layout and how you essentially manipulate the mesh gradient is you have a two-dimensional array, a two-dimensional grid with, think of each cell containing a specific color and a certain position. And if you mess with the colors and mess with the positions, you actually get a mesh gradient. It's got really good smooth blending, extremely customizable, and apparently it's got metal under the hood, so it's got GPU acceleration behind it. It's easily animatable, so you can just plug in a state variable and just animate your mesh gradient. And it's got really good versatile usage. So this is an excerpt I put together with a bunch of different sources. So let me read this out. Mesh gradients in SwiftUI are a powerful and a visual, striking way to create complex multicolor gradients using a 2D grid system. The colors between these points are smoothly interpolated, creating a fluid, organic-looking gradient that can transition between multiple colors in any direction. Unlike traditional linear or radial gradients, mesh gradients offer fine-grained control over color distribution, enabling the creation of rich, dynamic backgrounds or UI elements. So let me actually get into the syntax. This is the simplest syntax you get for mesh gradients. So you have the width and the height. This is going to denote the number of rows and columns your grid system is going to have. Points, this param it accepts an array of vectors with each vector taking in two 32-bit floating point integers. And then you have colors, which is essentially just an array of colors. And each color you specify here corresponds to the specific vector. So this is going to denote the position of this color in this 2D grid. So this picture is, I put this easy picture together. So think of like each color as a point in this image. So as you push and pull these colors position, this mesh gradient kind of creates this fluid flow to the mesh gradient. So I'd like to talk about the points param in specific. It was a little hard to understand, especially if you've used CG points. So think of 0.0 as like the start of an axis. So left edge for X, top edge for Y. 0.5 represents the middle point of an axis. 1.0 represents the end of an axis. So right edge for X and bottom edge for Y. So this is an example of what you'd fill the points param with. So in this example, I've created a 3x3 grid, and I've added in the positions for each of these colors. And as you can see, this is what it renders. So to quickly denote how I can change this mesh grid, let's change the position of the color in the second row, second column, the green color, to make its x-axis 0, right? As you can see, what happened is the top right indigo color and the blue on the middle row, they've taken over. So yeah, this is a quick example of a very, very simple representation of like how you can quickly implement mesh gradients. So next, I'll be talking about TextRenderer. This is a protocol introduced by Apple in iOS 18 and gives you very low-level control over how text animation is rendered and its behavior. So it's got really good custom rendering control. You can create dynamic text effects. So it's GPU accelerated. So I could be wrong about this. I guess it kind of uses metal under the hood, so I'll have to check on that. So sorry about that. It's got really flexible layout handling. So this is another excerpt. So sorry, I'll just read this out. TextRenderer is a powerful protocol that allows unprecedented control over how text is displayed and animated within SwiftUI applications. It can create rich dynamic text effects, previously challenging to achieve. TextRenderer works by intercepting the default rendering process, allowing custom rendering logic to be applied before the text is displayed. With this, we can create unique visual effects, improving performance for animated text and implementing complex text transitions. So when you implement the TextRenderer protocol, this is the method you'd have to conform to. So the text layout param is, it provides information about the text to be rendered. So essentially like how many lines, things of that sort. And the context is, it represents a graphic context in which you modify and draw. So this is a kind of nested for loop I put together. So layout contains the lines, the multiple lines you have in a text, and then line contains multiple runs. Runs are kind of like, think of them like a sequence of text or characters that have that follow similar font or similar structure. And then each run contains all the glyphs. So glyphs are kind of like smaller shapes that kind of form a single character. So this is a quick example. What I'm doing is have something called simple text renderer. It conforms to the text renderer protocol. And then I iterate through each line of the text. I calculate the progress based on the line position. And then I adjust the opacity from top to bottom. And then I also apply a blur effect from top to bottom. So that was text renderer. So I put together this extremely simple, really, really simple example of mesh gradients and text renderer working. I probably didn't do text renderer justice because my Xcode 16 was crashing when I was trying to do some stuff. So I'll go ahead and play this animation. Again, the text renderer is it's a very simple example. So as you can see here, I added a state variable to the mesh gradient. It's kind of just animating the mesh gradient. And then I use text renderer to kind of add a specific color to the last word of the sentence. And you can play around with this. Like I was able to add like really beautiful render blur animations. I was able to like make the text wiggle, so forth. So yeah, that's it. That was my simple talk. So thank you.
So hi everybody, slide one. Yeah, I'm Greg. I work here at Radar here for a few months. We do a lot of location stuff. We do a lot of stuff that has to do with where you are. And as Tim mentioned, billion API calls a day, which is a staggering number. But a lot of these calls are about people that are in their cars and walking around, and they're sort of mostly outside. And the outside world is pretty good with location. Indoors, it's a little bit harder. So that's what I want to talk to you about. first question that I ponder and kind of like spend a lot of time thinking about, what is GPS? And really the only way that I can now talk about it is that it is a marvel of technology. This is a page that I think just goes on Hacker News every 6 months, and it gets like 1,000 points, and everybody just how it goes. This page is also a marvel of technology, so it's like a double marvel. This is a page that you should show to any child that you have, anybody that maybe is having a rough time in their life. Just give them this page. This is absolutely the most beautiful web page that goes extremely. It's very, very kind of like soft and kind, and just talks to you about. Let's talk about how can you know where you are, and how about if there's like some points and you know how far you are from one point. And it's like really gorgeous. You can drag stuff around. It's hyper interactive, and it starts talking about time, drones that fly, and then it just goes on, then talks about bias and time and clocks, and it still goes on, and then it goes on in 2 dimensions, 3 dimensions, and math, but not scary math. And at some point it goes into space, because we need to talk about GPS, and GPS is the satellites, and there's so many of them, and what changes if you're far away or close to Earth. And it keeps going, and this thing too is really cool. You can like drag it, and then it will try to fly, and that's not good enough. Oh, this one just goes always to Earth, but the next one, you can drag it. Okay, this wasn't a good satellite. This is a satellite that just left Earth forever. This one, yeah, this one actually is a satellite. And what is that? Well, it's just Kepler and more equations, and you can play around with them, and like more equations. And at some point, GPS, and why aren't GPS satellites geostationary? Wouldn't that make more sense? No, it would be worse. And they explain that to you, and you can also read about that. And then at some point, they're like, okay, so you have satellites, I believe you, they're in the exact right place where they should be, but what is the signal that we get from them? And this is the third part, where they just go about how incredibly just complex and subtle it is to send a signal from those satellites, from multiple satellites, to get the signal, to understand what the signal is. It's fascinating. I love this webpage. I could just do a presentation about this webpage. But the problem with the GPS signal is that indoors, it doesn't really work. So it works, and actually, I kind of like just remind myself, maybe I'm crazy, maybe it does work, maybe I'll, everything I'm doing is not really like worth it. So, I open Google Maps, iOS, zoom in, and you get this big circle. And right now, I'm there, like in the street, and I'm not there, I'm here. So what's the problem? Well, the problem is the GPS signal is really, really, really faint. This like radio approximation is it's like a 50-watt light bulb from 12,000 miles away, or 20,000 kilometers. So yeah, also in terms of watts, not that it's a unit that's like so, intuitive, but a millionth of a billionth, that's a really small amount of watts. Typically, like phones will be about 100 milliwatts, so like 100, but not a millionth of a billion. It's super, super faint signal. Once it's indoors, once there's like, roofs and other floors above us, you lose the signal. All right, so let's just to talk about signals a little bit, and this is also a little bit of a relation to the WWDC. When we talk about spatial computing, because I think a lot more indoor stuff is going to be happening that stuff. We're talking about a bunch of sensors, and our phones have a bunch of sensors. This is also, I'm sure you also like love these web pages. I love the one that just goes and it has like all of the sensors that it has, right? Like where's that list? Yeah, so got the GPS, it's got UWB, it's got obviously you can detect. There's a really cool party trick. I recommend trying it. Your phone can detect, because of the compass, if you get it close to metal, you can sort of use that as a cheap metal detector. It doesn't really work, but like for beans, it actually kind of does work. One sensor that's like blows my mind, there's a barometer, like the actual height, like pressure. And I have a friend who just did a blog post where she went in an airplane and she just recorded the barometer on her phone, telling her the air pressure in the plane using her phone. That's insane. Okay, what does that have to do with location? Almost something. Sorry, I got a big thing that I need to move out of the way. Otherwise, I can't see it. No, not thank you. Too early. This. Yes, okay. GPS, Marvel, let's go. Okay, so what does work or doesn't work as what R&D is? Just trying to move this. It's incredibly complicated. Okay, here we go. So one thing that you might have heard, or you might have, think or know, is that Wi-Fi routers. There's Wi-Fi routers around us, and they're usually pretty, they pretty stay in place. You don't really move Wi-Fi routers. And when you go into your list of Wi-Fi networks, they're pretty unique, right? And they have an SSID, which is unique ID. So couldn't we use Wi-Fi routers to know where we are? And does anyone kind of know why we can't really do that? Does anyone kind of come to mind? This is like an iOS, Apple Apple thing. So I don't even remember what the first link is going to be. Oh, the first link is pretty cool. It's like a map of all. I don't know. I'm clicking allow on your phone. I'm really sorry. I just allowed every single permission. This is a map of paths of routers, Wi-Fi routers that are mapped in New York City. It's kind of crazy, right? So people call this WAR driving. They kind of drive around. I don't know why WAR is involved. But they kind of locate Wi-Fi networks, and then they go, okay, I see this, this link says this, so etc. So we kind of know, so to speak, where Wi-Fi routers are. But can we use them in our apps? No. Apple forbids us very, 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 very much from doing that. And so you can, in your iOS app, go, hey, can you just give me the list of Wi-Fi networks? That is not a thing that's possible. And this has been the case for like many, many years. So there's a very special permission. And you need to like develop hotspot. So if you're helping somebody with your app connect to a Wi-Fi network, you are allowed to see the Wi-Fi networks. But you can't do that if you're just like a regular app. So just going back to my presentation. All right, the accelerometer. This is also something that people kind of think, right? You can kind of use your phone, and if you move and you move again, that kind of motion that I just did, you've like accumulated, right? And you can do math. You can know where you are. Again. This is both possible and not a good idea. So of course you can get accelerometer data. This is right here. Everybody, you probably have seen these apps where you do this and there's graphs. However, there's a really great talk from I think so many years ago now. From 2010. Really, really recommend this amazing Google talk. Given at Google. We're not going to go through it. There's a bit of math. It's but it's really good. This is actually the part that goes really crazy. I know there's no sound, and I'm just going through a video that I just know by heart. But this is the part where they go, okay, so you have error in your signal in the accelerometer when I did this gesture. And the problem is, as you're going through space, the error accumulates, and it accumulates so much. It's called the double integration problem. That you get an error of 8 meters of error per second. Every second you're off by 8 meters, and then 8 more meters, and 8 more meters. So it's really pretty hard to just use the accelerometer. You can, but it's pretty hard. All right, does anything work? Can we locate ourselves indoors? So beacons, you might have heard of Bluetooth beacons, and those work pretty well. We can, read them with our phones, and we can do stuff with them. So let's talk about that. I do not recommend looking at the Bluetooth spec. How many pages do you think it is? Let's take some bets. Before there's a number here. No. How many pages? 500? Okay. More? Oh, this is the number. I'm swapping the numbers. Yes. It's only 3,000 pages. So, I recommend if anybody is like, hey, but can you help me with computers? Can you help me with my Bluetooth? Just send them that PDF. and it really explains how complicated this is. Like, it's also a marvelous technology, but more on the when it works kind of side. So, okay, so Bluetooth is complicated. I do recommend one app. Really fun. So Light Blue. I'm sorry, I'm opening all these. Yeah, Light Blue. Looks a little bit weird, but if I just scroll down, I just really love the reviews, especially on iOS. Some of the reviews are like, I lost my Fitbit, but now I found it using Light Blue. Light Blue shows you basically everything that your Bluetooth sensor hears, and it's really, really cool. It's just like a cool little app, and it'll kind of open a world for you, hopefully, about how cool Bluetooth is. So, okay, so talking about Bluetooth, talking about things that are around. So beacons are things that you can, install in there, and you kind of know where they are, so that you can find them later, right? And you can situate yourself. But how about other devices? This thing, maybe this thing, maybe this thing. Probably not this thing, probably not the couch. But there are devices around this. And also, let me ask you, how many devices do you think in this office? I know there's a lot of people now, so kind of exclude yourselves. How many devices do you think just in this office? Approximately. Do you think there's one Bluetooth device in this office? That's ridiculous. Do you think there's 10? Still kind of seems low. How many things? Just throw a number. I'll move on. More? That's pretty close. Yeah. So depending on where you are, you can definitely get in the hundreds, multiple hundreds. Sometimes I've seen 200-300 devices just right here. It kind of doesn't look like it, right? But there's a lot of devices, a lot of even AC devices and stuff. So what can we do with them? Well, I'm showing you the easiest introduction to machine learning you've ever had. Hopefully this will just get you on a journey to learn more about machine learning. So here's 3 locations, kind of in the office, sort of, right? And you can imagine one location that's over there. There's 20 devices total. You don't even really need to know which devices there are. You just see that there's 20 in total. 4 televisions. There's a television there, there's one here, and 0 fridges. Right? So that's location A. And you kind of survey the space by doing this testing and count number of devices. And you kind of describe it, right? So if this kind of device, one for each workstation. And so this is machine learning, right? If I tell you, hey, I'm seeing 9 devices total, and there's 9 televisions, where am I? Yes? Is it kind of obvious? Okay. So that's machine learning. But obviously you can do more complicated versions of machine learning. All right. So in practice, what does it look like? Last slide. So what we do is that we actually survey offices, an offering that we're gonna have. You survey an office as we've done here many times, and you create this machine learning model where you know some things about some locations, and machine learning kind of like then learns something about the whole entire office, and it allows you to move around it and tell you where you are. And then when you actually use it, once you have the model, you do mini surveys, right? So as you walk around with your phone kind of like looks around, hears, and sees how many devices it sees, does the machine learning inference, and then the error is more on 2 to 5 meters. So this is really kind of like shows a really good example of why this is all worth it. The GPS, while we're here, sometimes puts us across the street over there. Also gives us the bubble kind of going, I think. And then, the person was actually here, or maybe here, where it was, 2 to 5 meters. Quote, I think this is my last slide. It is. Thank you, and we're hiring. Goodbye. Thank you.
Good evening. My name is Sean. I work at Capital One as iOS engineer. So today I'm going to talk about Swift performances. So as iOS developers, we normally don't really care about performances, right? Because memories are cheap, CPUs are cheap. But there are times there's problems, right? Because UI becomes sluggish, or maybe you're developing a system library, system service, where it's drawing too much daemon powers. So yeah, so today I'm going to talk about what John McCall talked about the performance in the in Swift language. So in this talk, he outlined 3 main points: the different performance problems we encounter with Swift, how we approach them, and some of the core principles we use to solve these problems, and also putting it together at the end where he talked about Swift features, where he dived deeper into different Swift features, how those how performance trade-offs are played in those features. So performance is hard to measure in iOS apps, right? So usually when you see a problem with performance, like UI, you kind of go from a top-down approach. You use instrument to measure, to profile the hotspots and to find out where the problem is. Or you can use timestamps, right? Putting a bunch of timestamps in the code and to pinpoint where the issue is. The problem can be usually solved with an algorithmic solution by changing the time complexity from a quadratic time complexity to maybe linear or even constant. But sometimes we just can't do this top-down approach. We have to use a bottom-up approach. And that's what we call microscopic approach. There are 4 principles when you're looking at a bottom-up approach: function calls, memory allocations, memory layouts, and value copy. So the first principle we want to look at is function calls. And there are 3 costs associated with function calls. The first one is argument passing. When you're passing an argument to a function, you can pass by reference. You can also pass by value, right? So imagine you're passing a value, which is very large struct. You might incur a lot of cost. So yeah, so that's one of the costs. The second one is static versus dynamic dispatch. So that's regarding to function resolution. So the question is, do we really know, what do we know at compile time exactly where the function is and what function we're calling? So if we do know what function we're calling and its definition, we call it static dispatch. Static dispatch calls always go to a specific function definition, and compiler can inline optimize it because you can see its definition. Dynamic dispatch is a little bit more expensive because you have to look up the V table. The call can go to different function definitions, and compiler must take conservative assumptions about the call. This is more expensive, but that's what enables polymorphism, make it more abstractions when you're making design decisions. Allocating local state. there's very little cost associated with the allocating local state on the stack because it's pretty fast. You're just basically subtracting the stack pointer from the stack frame. But when you're using when you're calling a lot of asynchronous functions, because tasks manage its own memory stack, you might incur some performance cost when you're doing a lot of async functions and passing large structs or values across the async boundaries. Principle number 2, memory allocation. You all know there's 3 types of memories: global, static, and heap. Global is great, right? It's very fast. It's in the binary, but the use case is very limited, right? Stack is also really fast. It's pretty much free, but the problem is, you only can work with values that doesn't live outside of the current scope. Heap memory is very flexible. Allocated at arbitrary time, you can deallocate it at arbitrary time. It's significantly more expensive, but that's what enables polymorphism, making more abstractions when designing your code. Heap memory usually have a shared ownership. Swift uses the reference counting to manage ownership. So when you're incrementing the reference, it's called retain. When you're decrementing the reference count, it's called release. Principle number 3, memory layouts. So how does Swift use this memory? How do we store this value? Like, what does it look like in memory? So in more technical term, we use the word representation to describe how value is laid out in memory. In this case, the variable array is the name for memory, and it holds a reference to a buffer object. Inline representation, it's just a portion without having to worry about the pointer. So as you can see, the array is just holding to a reference. So in Swift standard library, array is a struct actually, and it has one single property, a store property, and which is a class object. So when you're storing array in a struct or in a class, the inline representation of array is actually just a pointer. In this case, the memory layout of the array is just a byte, which is 64-bit pointer. So inline storage and outline storage, as you know, in Swift, there is a value semantics and there's, object or class semantics. So structs enums using inline representations, that means that when you're copying them around, you have to copy all its inline representations. Classes actors use out-of-line storage. When you're copying them, you're just basically retaining one pointer. So yeah. So if you're copying class, it's much easier. For example, in this example, struct person, let's imagine there's many store properties in this struct. And if you're expecting to make a lot of calls, passing this value and copying it, you might incur some performance costs because you have to copy all its store properties or inline representations. So sometimes it's better to use class or actor. So the next low-level principle is called value copying. There are 3 different ways that Swift the value behaves in Swift. The first one is consuming value. There's a concept in Swift called ownership, very similar to Rust, where they're all LLVM family languages. Ownership means managing the value's lifetime. When it's deallocating, when it's initializing. Let's say here we have a function make array in which we have we create a value of array of doubles assigning to a variable array. The array literal on the right-hand side of the operator or assignment operator, it creates a new independent value. So when we're assigning this value to array, we're basically transferring the ownership to this array, variable array. All right, so now let's define another variable, array2. Now, when we're assigning array to array2, because array doesn't naturally produce an independent and new value, we can't just transfer the ownership, neither because we might use the array later on the later scope of the function. So now we have to copy this array, assign it to array 2. The new keyword was introduced in Swift 5.9, which is called consume. Now you can actually explicitly say, I want to consume or transferring ownership from array to array 2. This makes sense because now if you're using array again on the later scope of the function, the Swift will give you a compiler error. Mutating value. Mutating value is pretty simple. It's very similar to Rust's mutable reference. Mutating value is when you want to take ownership temporarily and mutating it. After you're done the mutation, you give ownership back to the owner, which in this case is the array. Mutating is different from borrowing, from transferring ownership because the value expect the ownership to be returned. Borrowing value. Borrowing value is very simple because in most of the cases, borrowing happens when you just want to read the value. You don't want to do any mutation. You just want to read about it. And most of the times when you call functions, you're passing something to the function. You just want to read it, right? So that's when borrowing, just like immutable reference, you're passing to the function. So in some complex situations, Swift compiler doesn't always know when to copy and when to mutate, or sorry, when to transfer ownership. In this case, array is a store property of a myClass object. Because Swift needs to ensure memory safety, and it wants to guarantee there's no simultaneous mutation to the array that is stored within the object myClass. So Swift will like, okay, I guess I need to defensively copy these values. So now instead of print array, like what we had before, which you pass in immutable reference, now you have to copy it. And that's a little bit more expensive. And Swift is continuing to improve on the compiler level, like the optimization, making sure that it doesn't copy, it will just mutate, or just do a pass immutable reference. And also Swift is giving more, producing more, developing more features, such as the non-copyable features introduced to 5.9, Swift 5.9, to give developers like us, the explicit control of mutating or moving. In the rest of the talk, John McCall go into depth about how those low-level principles are applied in Swift features such as dynamic size types, async functions, closures, and generics. I don't think I have time for that because it is pretty extensive, where you go into a lot of diagrams, a lot of illustrations. I highly recommend you guys to watch the talk. Here's some links. The second link might be interesting to some of you. It is also John McCall. He talked about how the Swift language evolved over time, because Swift initially was developed with C++, and there's a large code base at Apple, like Objective-C. So the language evolution for Swift is quite interesting in terms of performance and safety. So the second link, it's quite interesting. That's it.
Hi, folks. My name is Chris. I'm a software engineer at Etsy. I'm also someone who helps Paul and Jordan organize this meetup. And I'm going to be talking about these new Zoom transitions in iOS 18. So as Paul mentioned, it's going to be live coding. I only have 2 slides. So here's our setup. We're going to be talking about how to do these in UIKit first, and then SwiftUI. So in UIKit, we've got a pattern that we see all over iOS. We have a view controller with several pieces of information, in this case photos, and when we tap any of them, we go from this overview view controller to a detail view controller. You see this in mail, you see this in messages, you see this in photos, you see this everywhere. And so wouldn't it be nice, instead of using this kind of standard push transition, make the text a little bigger here, instead of just pushing the view controller, let's do something a little more interesting. Let's use this new Zoom transition. You might hear this called a hero transition too. And you've been able to do custom transitions in iOS for years, but this is a very specific custom transition, and it's very straightforward to do now. So why might you want to do this? For reasons of continuity, like you can provide that to your user to help them understand what's happening, how this navigation is working, and also for a little fun, little delight. So on our detail view controller, we can set our preferred transition to a UI view controller transition zoom. And the initializer takes this source view provider closure. So let's clean all this up a little bit. Use Swift's type inference and trailing closure syntax here. So this source view provider closure needs to provide your view from your source view controller that you're going to zoom. And so in this case, we can just say, so our context here will give us both the source view controller and the zoom view controller. So we'll pull out the source view controller here, and we'll make sure it is the right kind of view controller. If it's not, we'll return nil. Otherwise, we'll just return our source view controller's selected view. And so now before, where we just did a standard push transition, when I tap one of these now, we're doing a zoom. And it's neat because not only can we navigate back using the back button, but we can kind of pull this down and do an interactive dismissal. It's neat, looks better. It doesn't look perfect though. There's still something missing here. And I think you can see it better if we look at this in simulator with slow animations turned on. And we can see what's happening here is we're zooming out from the right place, but we're kind of fading between the view controllers in an inconsistent way. Like this photo kind of changes places as it fades. And the same for all of them. And what's going on is we have provided the source view in that source view provider closure, but iOS doesn't know where to target in the zoomed view controller, the destination view. So how do we do that? We can provide that as well. We need some options to do that. So for that, we want some options, which are UI view controller transition zoom options. And you can change things like the background as you dismiss, and you can do a blur effect as you dismiss. But what I'm going to set on these options is the alignment rect provider. And this is another closure. And this is supposed to return a CG rect, which are the coordinates of your zoomed view in the zoomed view controller, the destination view controller, basically the area you're targeting. You start the zoom from this selected view, and then you target the zoom to this CG rect in your destination view controller. So let's pull that out. Our zoomed view controller will be our contexts zoomed view controller, and it's called a detail view controller in this code. And if we, for some reason, don't have anything, we're just going to return CGRect 0. And now my detail view controller conveniently has an image rect computed property on it. And so now when we tap any of these, it goes by quickly, but it's a little, let's see, oh, it doesn't actually do it until we add the options here. There we go. All right, so now it'll go by quickly, but it's a little more fluid, a little more continuous between the view in the source and the view in the destination. So that's UIKit. Let's quickly go over to the SwiftUI side of things and do the same. So this is set up in a similar way. Tap something in our VStack of images and go to a detail view. And we're just using the navigation link API for this. And so what we can do here is for each image, we can set up a matched transition. We can mark it as a matched transition source with the image ID in our current namespace, which we just have up here. And then on the detail view, we have navigation transition, style is zoom, and the source ID is the ID again, and the same namespace. And so now, with these two lines, we do a zoom transition. And again, we get the nice interactive dismissal if we just drag downward and standard back arrow to. And so you might be wondering, all right, so how do we set the alignment rect in SwiftUI? So I have to admit, I have not found how to do that in the API docs yet. Maybe it's not there in this Xcode beta I'm using. Maybe I'm missing something, but I will note, like, I have seen a blog post that says the same thing, where the author says he can't find the how to do the alignment recs either. So that is where I'll have to end it. I'm going to put up some references. Here's WWDC talk, a couple blog posts, and if you like this, you can follow me on Mastodon. Thanks.
All right, everybody. My name is Akhil Bodana. I'm an iOS engineer at Capital One, along with Paul and Sean here. And today I'm going to be talking about thinking about the qualities of design. I know there's been some really interesting, very technical talks today, but I thought I would try and switch it up and think about something that I think we either think about or work with a lot, but probably doesn't get talked about as much. And it's kind of a personal interest of mine. So I figured today I would talk about design. So design is something we experience every day. It doesn't even have to be about apps. It could be websites. It could be the car you drive, the bottle or can in your hand. Everything that we use or experience or interact with is designed in some way. And there's sort of 5 main ways or main sort of things that have to be designed or thought about. And so the first thing is type, which is like the text that you see here. There is sound, which is the things that you hear, the noises that machines make or intentionally make for you to hear or feel something. There's motion design, which is kind of how things move when you interact with them. And there's visual design, which is how things look, how they feel, and how they might animate. And there's interaction, which is kind of how the last few things sort of come together when you touch something or try to talk to something and it responds to you or does what you want it to. So with that, the main thing to think about is what is quality in design. When you're using something or interacting with something, how do you assess like if it's quality or not? And so for me, some of the things that I think about are, is it intentional, considered, and crafted? And what that means is when I'm interacting with it, can I sort of feel or sense the intention behind it and like the craft? When you sit in a really comfortable couch, can you feel the lines, the artwork, and even the engineering behind it? If it's something you're using like a tool or an app, is it seamless and easy to get the job done? Is the app like focused? That leads into the second point. Can you concentrate on the task at hand when you're using this thing? And then the last 2 points kind of tie into each other and kind of tie into what I said before, which is when you're using this product or this app or this tool, the designer's intentions kind of seep all the way down to the details. And if you're a user that really driving deep, you can typically kind of feel these things. You can tell that if something works a certain way, it's because someone thought about all the things to put it there in the first place. And so when you see that, when you notice that, you kind of think, wow, this is a quality product. And so that's kind of how I think about quality in design. And so the next thing is like, why is this important? Why does it matter that design has qualities to it? The first thing is that it's ubiquitous. It's everywhere. Like I said before, everything you interact with, everything you use, like it was designed, it was thought about, it was engineered in a way. And since you're thinking about it all the time, it must be important because clearly it affects the outcome of your interaction with it. And the intentions of the designer and the engineer and the builder will be felt. So like a funny thing that I saw on this topic was like, mom's cooking always tastes good. Like your friends may not like it, someone else may not like it, but to you it tastes good because you know what went into making that. You know what she was thinking about when she cooked it for you. And this kind of applies to other things as well that might be less personal. At a survival level, quality is critical. We eat things, we use things, we drive in things that move. We live in buildings that have to be safe. They need to function, and they only do that if they're quality, or they catch on fire, or they collapse. And we are inherently sort of built to understand that like something has to be quality for it to be useful. It has to get the job done quickly and safely. And sort of coming back to like the application and engineering world, you know, if you're building something for somebody and you are an individual or a small business or a large corporation, the app that you build is sort of your first or possibly even the only way you interact with your customers, and you know you want to build that trust. So I talked about, you know, quality of design and why it's important, and so now I want to talk about like how does this actually translate to what you're building. And so there's four sort of main themes here. The first thing is your app should be simple, like I kind of mentioned before. It should be focused. It should do what, you know, it's designed to do, what people downloaded in the first place to do. And so it should be quick to understand, and it should be predictable. You should use patterns that you might have seen in popular apps that you know people use all the time, that like every day. Think of an app that people probably use every day, like an Uber or Spotify. What are patterns there that work well that people are familiar with? And maybe just copy them. Maybe that's what's easiest. Visually stunning. We had a few talks today that talked about, you know, designing very fun little things that you can do that make your app just look good. And most people may not admit it, but they look at things and, you know, decide that it's a really good product, whether it's a car, you know, a condo, or just an app. Like if it looks great, you know, if you use the latest SwiftUI APIs, they'll probably download it. Everything you build should feel like a visual piece of art on top. And then, you know, the engineering is a different story, but start with the visuals. Make it timeless. So this was actually something that I kind of struggled to really portray in a way that's, you know, usable. But the idea that I extracted was try to make something that's original, that's your own idea. The example that I'd seen was like the iPhone ringtone, which I probably should have put on here, but you know, anyone that hears that knows that sound because it was unique when it came out. It still is today. And, you know, because it was original, it didn't try to follow a trend. It was just unique. And so over time, people kind of associate with that, whether it's a sound or your app icon or your brand, try to make it timeless. And then the last thing here is have positive impact. Like think about what the effect of your product is on the user. You know, it could be something like Uber, that's just a strict utility. It could be a dating app. It could be Netflix for entertainment and for good emotions. But at the end of the day, you want your users to actually have a positive impact on their life by using your app or your service or your tool, whatever it is that you're designing. And if you're thinking about that, I think like you kind of will have that lasting, you know, lasting value on the user. And then the last thing here is a few things that I sort of learned about techniques for actually implementing the things that I just said. So this first thing, I was like reading some quotes about type designers who like make fonts, and they were talking about drawing caricatures. So essentially they drew the letter N, and they all had different versions of the letter N that they didn't agree with. Crazy, I know. But then they drew it out as a caricature, so kind of like in like a comic book way, and turns out all the N's actually stood out in more unique ways. All the intricacies of like the height or the width stood out more, and actually it made it easier to sort of come to terms with like what everyone wanted in their version of the letter N. And it just created more visibility and shared understanding, which is kind of the main point here. So I think like a more practical example would be if you have a design for your app, whether it's a screen or how a button looks or how a transition works, just draw it out. Like maybe use FigJam or something, like get the ideas out on paper and then try and create understanding, because I think that's, if you're working with other people, if you're an engineer working with designers or you're a designer working with other designers, I think getting it out there is the main thing. And that leads into, you know, how to take your design from something you just thought of to something that might work. And so that's, you know, prototyping and testing your designs. I'm not a designer, but a lot of times, like designers that I work with are just kind of experimenting with things. And at the end of the day, they just will give us something that's like, yeah, you know, we think users will want this, but, you know, the most lasting things I think are designs that you've like created, experimented with. Do not make any assumptions, and you've actually like tested with users. Like go talk to them if you can, and if it's practical for your company, like try and, you know, give it to your friends. Do like user study groups. You know, that's definitely a thing. And be patient, because everything that you think you know about how you might use an app or a service just never ends up being true, because there's so many users out there and they all have different amounts of knowledge about things, and you just want to be very patient with that. The next thing that I think can be super helpful is feedback. I think this applies to design, but really just anything that you're doing. Have a good process for like receiving feedback, for sorting it, processing it, and then like figuring out how to execute on it. Because at the end of the day, you're designing for people, for someone else, not for yourself. And the only way you can know if what you're making actually works is by talking to them, getting feedback. And this feedback could be from people you work with, but also like, potential end users. The last thing in here is to be modest and mindful of people's differences. Kind of what I alluded to before, but basically this just means empathy. The app that you make could be in a different industry, it could be in a different country, it could be in a certain range of ages. And so all those things could be so different from what you know day to day, and could drastically affect like what they think is the norm when it comes to using your app or service. And ask a lot of questions. Again, ties into the last point. All these things basically go to say that what you think works may not work. And so ask why a lot to both yourself, but your teammates' work, and try and get to the same page. And that's it. I linked a few things that I watched that were interesting. You'll notice that the big inspiration for today's talk was the first two, which were 6 and 7 years ago, that are an hour long. I don't think that happens anymore. Yeah, like going down the years, there was a lot more interesting and inspiring Apple design talks. And this year there's like 6, and they're just like about, I think, SwiftUI and SF symbols and stuff. So yeah, there was this one talk about UX writing that was interesting, which talks about like, really dives into like every single word you put in your app, like think deeply about what it says, because, you have a few sentences on a screen, like people will judge your entire app from like the onboarding experience, for example. So yeah, that's it.
I'm Julie. Happy to be here. Haven't been at iOSoho in a long time. And here to talk about Apple Intelligence. Just one last thing, right? So just a little bit about myself. I'm actually on a bit of a career pivot into AI. That's why Paul invited me to come and talk about this. I haven't coded professionally in Swift and iOS for 3 or 4 years. But I'm like kind of doing a pivot into AI. I'm just really excited about it. I think this moment that we find ourselves in is incredible. I never thought I would live through it in my professional years. So just, finding ourselves in this moment, I want to go be a part of it. So I'm on this career pivot into AI, and I thought, like, I was watching Apple, the weeks and the months before Apple did WWDC, just like, what are they going to do? Because the thing that's so crazy about Apple is they have the opportunity to put AI in front of so many people, like all at once. And so we're about to see that, right, with Apple Intelligence. So this talk, we don't know a lot about what we're going to see. We know what they promised in a sense. And I'm going to go over kind of what they told us. But I'm going to try to analyze what that tells us about their product strategy, and I don't know, maybe a little bit of like, looking at what maybe this tells us about what we might see in the years to come, and then what might be available to us as developers. So I just wanted to kind of note where Apple was in this whole thing. I mean, we had ChatGPT was launched end of 2022, and Apple really hadn't said much since then, until this year, until WWDC. I mean, and over that time, like, the hype was huge. Everyone's announcing their AI strategies. Just everyone's talking AI, and Apple really wasn't saying anything about what they were going to do, which is kind of normal for Apple. So, so that's normal. It was crickets for a while, right? Until May, when we found out that they were partnering with OpenAI on something, right? We didn't know what yet. And so there were these few weeks before WWDC where we were like, what are they doing with OpenAI? And so that was, we were kind of on the edge of our seats. WWDC comes. And this fun, everybody jumps out of an airplane. That was fun. And the whole talk, the keynote unfolds and nothing's really mentioned until the end when we find out about what they're doing with Apple Intelligence. Okay, so what to say here? I mean, we still don't. We know. We'll go into what we know, what they told us, but we don't know everything we're going to get. We know they promised all of this stuff across their app base, but that is kind of what we know right now. Is basically Apple Intelligence is going to be bringing language model, computer vision model stuff to Apple apps and their products right now. That's what we know, is that we'll be able to interact with Siri, still under voice, but under text, but we'll be interacting with these models, like mostly through Apple apps for now, which will be exciting and fun. But as developers, we don't necessarily have a way in yet, although I think we may know how we're going to get in later. Yeah, so but it's interesting to look under the hood. So let's look under the hood. What have they told us? This blog post was put out over the week of WWDC right at the start. If you haven't seen it, it is really good. It kind of describes all of what they've done with all of the foundation models that they're using on device and in their private compute servers. So we'll talk about what they've said they're doing across both of those to bring like AI experiences to users. But this is definitely a fascinating read. I realized I didn't put links in my last slide, but I'll do that. And then when we send all this out, they'll be at the last slide. But this is really good. It talks about the two areas where they're going to be bringing like AI capabilities is on the device, which I'm going to look at what they're doing there in just a second, and then the cloud, the private cloud compute, which we know less about other than all their promises for privacy, which I'll talk a little bit about too. But on the device, what we're getting is, I mean, ChatGPT will be accessible on the device, but what we know is that they're bringing their own models to the device, models that they've been working on for some time. We don't know how good they're going to be, but they have to be small enough to run on phone. So they, it can't be like a ChatGPT 4.0 or anything advanced like that. So they're, let me see, my next quote here. What they're doing to kind of make it all work is they're introducing these adapters. Let me quote this. So these are small neural network modules that can be plugged into various layers of this pre-trained model. So there is like the one model that they're talking about in here that's going to go on the device. It's small, it's nimble. They've been working on it for a while. It's fine-tuned. It's not fine-tuned to any one task. So the way they're getting it to do the different things that they need to do across all those promises, like, compose an email, like make a calendar event, is they've created these like adapters that will plug in at the different like neural network modules and be able to like enable these types of things. So the document, or the research document I mentioned, goes into a lot more detail. It's really fascinating. But there's a little bit more here. So there's small collections of model weights that are overlaid onto the common base foundation model, and then they're dynamically swapped in and out depending on the task that needs to be happening. So this is giving that one foundation model the ability to sort of specialize on the fly for the task at hand. And so they're going to be building some intelligence to kind of swap these adapters in and out and to like create the sort of sequence of tasks that need to happen to accomplish whatever you've asked for. We'll see how good this is, but this is their on-device capabilities. So this is kind of talking about what happens after that. Not everything can run on the device. So for what they've promised is that they're going to try to run it on the device for privacy and performance purposes. But then they've also introduced this private cloud compute like space where it's going to go next. there's a little bit of hype and a little bit of, you know, this hoo-ha around this. Like, you know, do we want our data going out to a private cloud? But I'll talk about that more in a second. And then as a last resort, and this is what we didn't know before, is like, where does ChatGPT going to come in? And actually what they also said in the keynote and later is that they're actually going to open this up for any other large language model. So we'll see, you know, Claude on there, we'll see Gemini on there when ready. But but apparently, like, nothing is going to go. The stuff that's going to go to those are just like, if we can't run it on the device and we can't do it in the cloud compute, it's going to go to these guys, and none of your private data is going to go there. So we'll see. We still don't know a lot about this yet. I think I'm not even sure they know exactly how they're going to do it. But this is what they've said for privacy, is that you know, I guess they've made a name for themselves in privacy in the last, like, you know, 5 to 10 years or so. So they're betting on that gamble that, like, you know, you can trust us with your data. If we put it in the cloud, we promise we'll delete it when we're done. We'll see. It should be interesting, you know. But the thing is, yeah, so we're all the app developers. What's here for us? Like, honestly, everything that they announced is stuff across their suite of apps and tools. Like, what are we going to be able to do with AI or these models that are on the phone? And honestly, I think it was kind of crickets again. I don't know if anybody else noticed any mention that I didn't, but they didn't say anything was here for us, right? So there's a lot of talk out in the, like, you know, ether about what is the future for apps. If we're in a world where we're going to talk to Siri, or, you know, whatever, we're going to talk to our phone and ask for things. There's a lot of mention around this idea of headless apps. So we might be heading in a direction where apps don't have as much UI. I don't know. This is like potentially years down the road, but this idea of headless apps are like, you know, you would talk more to Siri and get your stuff done without as much of a UI. And if that is the future, I think that future is enabled probably by app intent. Like, they did release a bunch of new stuff with app intents. They didn't say anything about, like, AI being a part of it. And honestly, nothing they really put out with app intents was like that impressive, or getting us that much closer to, like, you know, profound Siri capabilities for your apps. But this is kind of what I reckon and see is probably coming. Like, they're going to first shore up their apps, get this model onto the phone, and, you know, like, troubleshoot it for maybe a year, maybe a few years, I don't know. And probably it's going to come to us via, or like that Siri intelligence is going to come to us via app intents. That's my prediction. So that's it. I'll put my links on this slide when I link out at the end. And yeah, I'd love to see if anyone caught anything I didn't that should be mentioned. But yeah, come and talk to me after. It's fascinating to see. And I think, like, yeah, again, Apple kind of has a unique opportunity to bring, like, AI to so many people. And I think they're doing it in a really product, like, intelligent way, because they're just kind of meeting people where they are in the tasks that they already do on their phone and improving them just in small ways across everyday use. So that's it. Thanks, guys.